Let's get this thing started. All right, so by show of hands, who's interested in getting their OTP? Oh, wow, all right. Can you guys hear me now? All right. All right. So we're gonna go ahead and get this thing started. So this is a crash course in intro to pen testing. It's basically gonna cover a lot of stuff that you're gonna have to learn in the OCP anyways. Is everybody here obviously have Cali? Does anybody here not have Cali? Okay, good. All right, so who am I? No one cares. So what is penetration testing? So long story short, pen testing, of course, as most of you know, is the testing and evaluation of a system security posture through somewhat intrusive or very intrusive means, going beyond the scope of just vulnerability assessment. The thing that makes it legal as opposed to hacking is that, of course, you have legal permission. And note that pen testing is kind of mission driven, meaning it's not always about, take this thing off the stand here. It's not always about just getting root. It's not always about just, pwning someone's machine. You might be sent on an assessment to extract information. You might be on assessment to, we're probably not going to DOS somebody, but you have a mission, right? So if you can exfil data and that's the extent of your mission, then exfil data. You don't necessarily always have to get a root shell, but you can do it, right? I have to go with the basics, so bear with me. So different types of pen testing. We have white box, gray box, and black box testing, right? And so what they really refer to is the type of access and knowledge you have before you do an assessment of a system. So you all can read, but white box means that you usually have a decent to full amount of access to documentation and knowledge of the system prior to assessment. Gray box is kind of partial, and black box is sort of just figure it out, try harder. So the things that we're going to be covering today are basically the reconnaissance, scanning, and gaining access portions, or gaining access as an exploitation. We're not going to worry about maintaining access covering tracks today because we've only got 3 hours, and I'm sure there's going to be tons of debugging troubleshooting. Did anybody download the VM off GitHub? One person. All right, maybe two. All right, so if you look in the Slack channel, you guys should already have a link to my GitHub. And if you go to it, I have quite a few. There should be a link to, there should be three Dropbox links. One has a presentation, and there's a VM, whether you're using VMware or VirtualBox. So if you're using the VMware version, make sure you download this one, et cetera, et cetera. You may want to have the presentation. Now, in theory, most of you, if you have some decent Linux foo, you should be able to use this presentation, walk through it yourself. So if you're late, then feel free to go ahead on your own. So what this course is going to comprise of is sort of an explanation followed by an exercise. You should have a Kali VM already set up. I'd imagine most of you do, and you should have the VM that we're going to use for this exercise. So I'll give you guys, yes, question? Host it outside and put in a host-only network. Yeah. So you just go to GitHub. I'll repost it in case anyone doesn't have it. So it should be in the workshops. Yeah, it's gonna be a zip file. So I'll give you guys 10, 15 minutes to get that done, and hopefully your internet speed is half decent. We'll get started. If anybody needs help setting up their VM, their victim host, we have a wonderful team of helpers back there. So just raise your hand if you need help, and we'll get you squared away. All right. So when you're training for this thing, a few tools you should understand or know about. Netcat. By show of hands, anybody use Netcat or ever heard of it? All right, so it's like 4 people. All right, cool. This will be fun. Wireshark. All right, so a lot of people have heard of Wireshark. TCP dump. Those tools useful just for capturing packets, network traffic, stuff like that. You might have insecure protocols like HTTP, FTP, so you might be able to find credentials in plain text. Somewhat helpful, not so in today's world, but you'd be surprised when you look at the real world. Directory brute force tools. You're doing web applications, but we're not going to cover that today. It's more of what you guys are learning in your CTF. If you want to learn about that, we can finish a host portion, do some stuff after. Long story short is there's going to be a ton of stuff that you can learn about that you're not really going to remember. If you've noticed, Cali's got hundreds of tools, like lots of tools. One thing I do want to make note of is when you're running a lot of tools like TCP dump and netcat and map, all that fun stuff, use multiple terminals when you're doing different concurrent processes. So for example, I've got my terminal up here. So if I do something like, I don't know, TCP dump, I'm going to listen on my loopback interface. Let's go ahead and split that. So notice, most of you will probably already know this, you may be familiar, but this is a running process. This is a living process, right? So I can't type other commands like ls and like WTF. That's not even a real command. It's a living process, right? So I do something like ping myself, because I have no friends. I'm going to ping myself. Pinging myself. All right, it's a running process. You can see it capturing traffic and all that good stuff, right? So the point is, do not kill living processes to do other processes, right? So if I'm going to do an nmap scan on myself and I want to capture the traffic, all right, here, let me show you exactly what I'm talking about. If I don't know what I'm doing, I'm going to kill the process that I'm using to capture, and I'm going to nmap myself, hoping I can capture that traffic. It's not going to work because I killed the thing that was actually listening, right? So just be aware of that. There's going to be a lot of concurrent processes, and just keep that in mind as we move forward. All right, so basics. What are basics? Things like Wireshark, TCP dump, you're welcome to use either or. A lot of people use Wireshark, they're comfortable with it. Some of you've done like networking courses, all that fun stuff. I'm going to use TCP dump for this one, but you can use whatever you want. I don't care. I won't judge you. Well, quietly. TCP dump is nice because it's on a lot of Linux systems. So if you own a system, shell somewhere, and you're trying to listen for traffic within the network, well, you don't have a GUI. So, I mean, they may not have Wireshark installed, but, you know, live off the land, use what's already there. So for this exercise, put that. For this exercise, we're going to use TCP dump to capture traffic. So we're going to look at TCP port 1337 because we're late, and we're going to sniff for ICMP traffic. So if you guys have the presentation, you should literally be able to just copy and paste this command. All it's saying is we're going to listen on port 1337. We're going to listen for traffic on port 1337 or ICMP. So it's really going to do both. The -I specifies the interface, and the -LO is your loopback, meaning your own testing interface. You don't have to memorize these flags. Like every time you forget something, Google it. It's the way of the world, right? It solves all the problems. The -AQ just means also capture the data portion of the packets you're capturing, because we're going to create a netcat listener and actually look at messages in plain text. So I'll give you guys about, say, 5 minutes to get this one, and we'll go and review. All right, so let's go and go over that really quick. I think everybody actually got that fairly quickly. So, okay, so I'm gonna clear this, for that directory name. All right, so the first thing we did was run TCP dump. So TCP, can't spell, dump. I really can't spell today. We're gonna look for port 1337 or ICMP traffic. I'm gonna specify the interface as loopback, and I want the data in the message block with neat presentation. Boom. All right, yeah. Sorry, I thought everybody had like eagle vision. I wear contacts, leave me alone. Oh dear. All right. I'm scrolling back, it's getting bigger. There we go. Oh, apparently I made a smiley face in my terminal by accident too. All right, moving on. All right, so over here, if you ping yourself, ping 127.0.0.1, you start to see the ICMP traffic going to TCP dump or Wireshark if you're using Wireshark. And there it is, right? So a couple different pings. You see localhost pinging localhost and the replies. So it's fun, right? So the whole netcat listener thing, we create a listener, open up TCP port 1237, and we split that terminal and connect to it. So note that when you're doing the connection to not creating a listener, you don't need the -p flag. In fact, netcat will probably yell at you if you use it. So NC 127.0.0.1 on 1337, and boom, there it is. You see yourself connects to yourself because we are sad and have no friends. So send myself a message. Hello, friend. And you can see that message in plain text because it's not encrypted. And I reply to myself, go away, and there it is, right? So that was that exercise. All right. So this is just a fancy diagram basically showing exactly what I just went over. You see the listener, the connection to the listener, and the message in plain text. So reasons why that's important is you're going to be basically set in a bunch of labs and doing a bunch of exercises where, and some of you might be on Hack the Box already, you see this all the time. Basically things running in the background like FTP, scripts running, HTTP traffic. If you're looking for an entry point in a system, unencrypted traffic is usually a nice way to go, but you don't always get that blessing. All right. So now we're actually going to start exploiting things. One of the biggest issues you're going to have isn't host discovery. It's actually the easiest thing. I just want to kind of work you guys up a little bit. So before you can attack a system, you kind of have to know what's on your network, because what are you going to nmap if you don't know what to nmap, right? And you can do so with a couple different tools. So we have, I just said nmap, which can be used for a crap ton of things. I mean, you can service enumerate, you can do port scan, you can do a host discovery, you can do vulnerability scanning, you can even check for eternal blue. I mean, it's quite amazing. But in the real world, it's like really slow. But if you're trying to get your OSCP or a cert like that, it's going to be your go-to, right? Other things you can use, we have ARP scan, which uses ARP to discover hosts. There's also net discover, which basically does the same thing. And if you really want to, you can create your own Python scripts. You can use bash for loops to recursively ping entire subnet, and so forth. I mean, it's pretty much the easiest part of it. You can kind of faintly see in this image, I run like nmap-sn, which basically signals nmap to do a ping sweep of my entire subnet. So we're going to go ahead and learn how to do that. All right. So on your machine, go ahead and we'll use nmap for this one. You can use all three if you want to. I think it's kind of extra. They all do the same thing, so who cares? But just remember to use your subnet in the scan. So don't copy and paste my subnet. All right, moving on. So host discovery. So what did we do? Some people did ARP scan, some people did nmap. I mean, there's a bunch of different ways to do it, right? So in my example, I ran nmap-sn, and I took my subnet, which is 192.168.116.0/24. Ran that scan, and a couple different results came out. So at least with VMware, and I saw VirtualBox kind of does the same thing. VMware makes a .1 and a .254. Those are services. Well, .1 is my own PC, like my physical PC, and .254 is the DHCP server. I already know I'm .135 by running an config, so common sense deductive reasoning will state that my enemy, or my victim, same thing, is 192.168.116.132. If you had VirtualBox, probably heard me come around 1,000 times. .1 is, again, your PC, and .100 is a DHCP server, and it looked like everybody did a pretty well job of finding their targets. So let's do some enumeration. So port scanning, right? Once we figured out who it is we need to attack, now we want to identify what ports are open because we need a way in, right? Enumeration is the most important thing you're going to face, especially in a challenge like set certification, right? If you don't have a way in, you're not going to get in, but you need to find out what ports are running. So that's where we have this wonderful thing called Nmap. Real world math scan and unicorn scan are also great. You can do a Python script, you can use netcat. Netcat can actually port scan. But we're basically going to try to probe at every single port. Well, depending on your flags. In this example, I did Nmap. I specified ports 1 through 65,535 because that's how many ports there are. Notice I'm only doing TCP. And I specify the IP address that I am trying to scan. In my case, .132 is my target. As a result, yeah, that was awful. As a result, at some point, you're going to basically get a listing of ports running on that system. Okay? That's the first step. Once we identified what ports are running on that system, we need to figure out what is behind those ports. Because if I'm a sysadmin, can I run SSH on port 80? Yes, I can. I can run on any port I want. I can run it on port 22, 23, 11, you name it, because it's configurable. So don't rely on a basic Nmap scan to assume that port 80 is always HTTP. Now, luckily for you, I didn't troll you guys that hard, so port 80 is in fact a web server. All right? So after you identify the ports, pass that again to another Nmap scan for heavier enumeration. So we have what's called aggressive scanning, where we run scripts against the ports that we discovered, and we try to extract information from said ports to identify what's actually going on over there, right? So in this case, go ahead and run Nmap, specify the IP address of your target, and we're going to specify the -T4 flag to basically just make it a faster scan unless you guys want to wait here till tomorrow. Right? If you want to, you can specify the -P flag, which allows you to select what ports you want to scan. So you want to do 1 through 1,000, you can do that. You want to do 1 through 65,535, have fun waiting. And afterwards, when you identify what ports are open, try out the second command here to enumerate these services. All right, I'll give you guys 15 minutes. Since everyone's Nmap scans are going to take a while, I'm going to go ahead and run mine just so you guys can kind of see what it looks like. I'm sitting here crying. Wonder why I ever wasted my time. I can feel this, baby. Where's this something? Oh, you say you have for me. Oh, I can touch it, baby. Seems like nothing ever really feels the same. Oh, you say you have for me. I can touch it, baby. Seems like nothing ever really feels the same. I can see your heart in your eyes. All right, so this first Nmap scan, very basic, right? Nmap, intensity, the target of interest, and that basically gives us a listing of ports, right? So we simply pass those to Nmap with aggressive scanning, specify the ports that we've discovered so we don't sit here until next year, and we sit here until next month instead. Still takes forever. Just bear with it. Nobody's gonna say when I hold my, you're my broken heart. You're gonna let me show you how. It's so safe, some things have changed. I couldn't stop me saying no. So safe, won't take blame. All right, so we'll take a quick look at our scan results, and there's sometimes too much information, sometimes not enough, but whatever. So me coughing up Tivana. All right. So we notice there's SSH running, somewhat relatively old version 2.9p2 for OpenSSH. Gives you host key information, even tells it supports SSH version 1. We see that on port 80, we've got Apache 1.1.3.2, Unix. It even tells us that it's Red Hat. Gives us the modest cell and OpenSSL versions. Pay attention to that kind of stuff because you're going to be finding publicly known exploits for this cert. So look at those numbers, Google, literally just Apache 1.3.20. Look for a public exploit. See if something's already been developed. And if you're crazy, develop your own. RPC bind, usually never, my experience hasn't really been fruitful in terms of the way in. It's usually something wrong with the service version, somebody running a vulnerable service. So if it's not that, you may want to take a look at what's on port 80, browse certain browser. Same thing with 443. We notice that on port 139, Samba NetBIOS is running. That is commonly vulnerable. I'm sure that's part of the CTF. You're welcome. Let's see. Tells us what ciphers are supported. It tells us there's a port 31337. I can't imagine how that got there. I promise I didn't do it, or did I? And then we've got this other port that's bound to RPC. Right. So look at the things that are kind of suspicious. Keep note of those, but the really important takeaways to identify service version numbers. That's one of the first things you really want to do. All right. So speaking of which, we're going to go ahead and start looking at NetBIOS because the purpose of this exercise, that's our way in, right? All right, so Nmap is down. So I'll give you an example of service enumeration, right? So we'll take a look at port 139. It's hosting Samba, which is Linux file share service, basically. So just some quick background. SMB is server message block, so basically a way that we share files, just like you do on Windows, right? Same thing, but it's on Linux. In this case, this Genius is running an old version of it, which has many publicly known exploits available for, waiting to be picked and exploited by us. So the thing about it is it could be a vulnerable piece of software, or it could just be a misconfiguration. And in this case, it's both. You'll find a lot of times FTP can be commonly misconfigured. People put their FTP root in their C drive, stuff like that. You laugh, but it actually happens. And in this case, you use like the Nmap scripting engine if you want to enumerate, or use other tools, but we'll use other tools, not Nmap for now. So let's go ahead and run. We're going to use a tool called SMB client to list the available shares of the file system. I'm sorry, the shares on the remote host, okay? So you're going to run SMB client space dash capital L. That means you're going to list or enumerate shares and specify the IP address of your target.
The days have been brighter. I felt less alone. But I am a fighter, so I am never letting go. I'm playing. I'm getting so close.
So you'll notice when you run it, it's probably going to ask you for a password. It clearly says right above that anonymous login was successful. So you can literally just mash away on your keyboard, hit enter, and it'll actually take it. So once you run this command, you should see a couple different shares. You'll see something like Samba share, one called Egg Basket, there's an IPC, admin share. You can see that it's actually, there's a comment that is running Samba server 2.2.1. Now that's something important to take note of. That's going to come in handy a little bit later.
The day
You could also use enum for Linux. I get a lot of false positives with that one. It will give you some juicy info, but I'm going to skip over that. And so once we've identified shares we can connect to, the next part is obviously to access it. And that's where we can use SMB client or even the GUI to do this. So example of such, if I open up applications, go over to files, you literally open that up just like you would in any Linux box. It's kind of similar to Windows. So you can do open files, go to other locations, do SMB : the IP address of your target, and literally just hit connect. And there it is, connected to the target. So you can see the shares that were listed by SMB client or enum for Linux if you ran it. And as previously stated, it allows anonymous login, so you should be able to literally just log into anyone as anonymous. So a login prompt comes up, says anonymous, not entering credentials, I don't need to. And boom, there I am, I'm in their file share. Now, one thing to know about GUI access is you're not going to see hidden files, which brings us to our next point. You can use a GUI, it's convenient, but you don't really, if your view isn't configured to show hidden files, then you're going to miss a lot of juicy stuff. So by changing your view options to show hidden files, we can actually see that there's a .bash profile, bash rc, bash history, which tells us we're clearly in somebody's user directory. So that's one method. You can also use SMB client to do the same thing. Syntax is in the presentation. So if we go to our terminal, I'll just do it manually. I'll give you guys 10 minutes, get caught up there, and just raise your hand if you're having any trouble with the commands. We'll come out. Alrighty, so we got a little bit of practice connecting SMB share. All right, so I'm gonna maximize this real quick. All right, so for those of you who were able to, it looks like everybody was able to download files, so it's pretty simple. You could use get user.txt, for example, if I want to download this file. Very similar syntax to FTP, so I mean, nothing too crazy there. We download that, it'll tell you it's getting the file of size 33, 6.4 kilobits, blah, blah, blah. That just means, yes, download is successful. I get the question a lot, where does it download to? The answer is wherever you were when you launched SMB client. So if you use Control Z, background, you can actually see I launched it out of this directory, right? So that means if I do an ls after I download a file, there it is, okay? For those of you who want to know how to upload, it's quite simple. So if we created a file, something like touch, say ABC123, created a file called ABC123, right? I could use foreground to bring back the SMB client that I backgrounded with Control Z. All right, so now I'm back in SMB client. So if I do an ls, I can see what's in there. And I'm going to upload my new file, right? So to do that, you type put your file, in my case, ABC123. They'll tell you to put it up there. We'll run an ls. there's my file in their directory, right? And if you use the GUI, there it is, right? I highly recommend you guys use this method if you want to get through the exploit part quickly. But if you have a malicious file, I mean, that's an easy way to upload it, right? So now that brings us to our next topic. All right, so exploits, right? That's why we're all here. We don't care about putting text files and things and not getting shells. We want the shell. So we're working with exploits. An exploit is essentially a way to exploit a vulnerable service, right? Or some kind of vulnerability. It's not necessarily the payload or the action to be performed, but it's basically, think of it like this. Right? If you had a missile launch, say you're not launching a missile somewhere, a rocket into space, right? The delivery system is your exploit. The payload, or the thing carried on, or in layman's terms, the thing to be done, right, is your payload. So if I use Eternal Blue to clone a bunch of Windows boxes and I want to pop over a shell, Eternal Blue is my my exploit. That's how I'm going to get in their system. The payload would be either a shell or pop the calculator.exe on your desktop or change the background to a bunch of unicorns. I mean, that's your payload, but the action to be performed. So in this case, we're going to use an exploit that takes advantage of a vulnerability within the Samba service that's going to give us a root shell on the system. Okay? There's many ways to find exploits in Kali Linux and on the web. If you didn't know, the organization that makes Kali Linux also maintains the exploit database. So they were courteous enough to provide a offline copy on Kali Linux. So if you're looking in Kali, we have a command called searchsploit, which is, I mean, this is a really great example because it's grep. But if you searchsploit and let's say the word Samba, it's going to search for every exploit in the database containing the string Samba, right? In this case, I'm looking for a very particular one, which allows me to execute code on the remote host. You're welcome. All right, Metasploit framework is another one. There's a lot of prepackaged modules that do what these exploits do. Basically, somebody was awesome enough to write a module to make our lives 10 times easier, which will work with Metasploit towards the end after you've done a lot of hard work to fix code. Just kidding, it's not that code there, not yet. Finding exploits on the web, same thing, right? Google foo, that's how you solve half your problems in life, especially if you're in IT or cyber or whatever it is you're doing. Exploit DB, the online version of our search exploit in case you're outdated. GitHub, a lot of exploits on GitHub. Ask any bug bounty hunter. Or maybe you'll find a link to somebody's unprotected Google Drive in NetSet. I mean, you can find stuff everywhere. For the purpose of this exercise, I've decided not to make you all sprout white hairs today. I gave you a working exploit. In the labs and in the real world, you're going to find yourself with code that doesn't work half the time. You have to fix it. Right? So learn how to debug if you don't already know how to. If your troubleshooting skills suck, partner up with somebody if you ever run into this issue. If you're practicing, it's good exercise. All right, so let's get to it. First thing I'm going to say a million times before we get started is read the damn code, please. A lot of people don't realize that while these exploits are out there available for us to use, sometimes it's by design, not for good purposes. Some scripts out there actually pop the first shells in your box back to another attacker while you think you're popping shell on someone else's, right? You're trying to exploit a target, you don't read the code, you compile some nice, beautiful C code that executes shell code back to an AWS instance in Russia. It's real, it happens, right? So in this exercise, we're basically going to locate and exploit. If you want to, open up this link, go to exploitdb.com. I don't know if you're supposed to block it or not. It's not really my problem. Just go ahead and take a look at it. But we're going to use the offline search exploit database on Kali. So we're going to search exploit space Samba. It's basically going to search all exploits for Samba. So we're going to walk through that as we can go through it. You guys can do this along if you want. I'd leave your SMB shells open for later, just saying. So search exploit is a command. Go and tell it what you want to search for. So Samba is the name of vulnerable service. I do that, and holy cow, look at all this data. Lots of exploits out there. All right. Does anybody remember what version number was running on the victim host? It's 2.2.1. Thank you. Right. So that means most of these are probably going to work, right? Let's see. Yeah, get to know this one. This you'll see this later. If you know what I mean. Let's see. The one I'm going to use for this one is the 10.c. It's remote code execution. All right. So if you guys haven't already, go ahead and start searching for exploit. If you want to pick one of your own, go for it. I don't care. Just don't cry to me if you can't figure out how to use it. For this one, we're going to use 10.c. So if you're trying to find out the true path of an exploit, the easiest way to do is locate command, right? So you basically take this somewhat shortened version of its path. You can copy that. Use locates. Go and paste said path. It'll give you the full path to the actual exploit where it is on the call box, right? Go ahead and copy that to your current directory. Someone already got their first root shell. All right, so we've all got the exploit copied, right? All right, I'll see the nose. Moving on. Anyway, let's walk through this thing. Yeah, we're gonna go and do the exploit now. All the heroes have arrived. Amazing. That's a lot of pizza. All right, so we got our exploit, right? If you look in the directory, right, this next part is going to be confusing for some. We're basically just going to compile an exploit and run it, but sometimes this can be very complicated for some, and that's okay. Don't stress. You're going to do it so many times, it'd be like walking. All right, so what do we have? We have C code, right? We're going to compile this into a working executable, which is by design going to attack a remote system Samba service, right? So we will do the following. All right. So we're going to use the GCC compiler, which is already built in Kali Linux. So we specify GCC space the code to be compiled, the -o flag to basically specify that we're going to output that into something, and we are going to name said something, right? So all right. So without further ado, GCC code to be compiled. We're going to do -o for output. And I'm going to call this something very sophisticated and elegant to call it potato. Right. All right, so now after you do that, you'll basically just have an exploit sitting there as compiled binary. My epic potato is about to get me a root shell. And again, all this is doing is converting, using GCC, we're converting a piece of source code into a binary. That's literally all that's happening, right? So go ahead and run that and you'll have your exploit. And after you do that, I've already specified in the slides what flags to use for this to make your life easier. But if you run it, it'll tell you usage. So in this case, we will do /potato, or hopefully you came up with a better name than I did. That's why I'm not allowed to name dogs, by the way. So /potato. We have this thing in the way as always. There we go. All right. So it says we use -b for platform. It's right here. Specify Linux, so 0. Use -b for verbose. That's basically just gonna give us more information about the, the activity, the output of the binary, and then basically just the IP address of your host. So 192.168. For like 90% of you, 56.101 remains different because we have more special. And when you execute that, it's basically going to brute force for the return address of the where is it? And then boom, you get this thing. This is what confuses the hell out of everybody. You get some kind of output, tells us we're root, and then some people are like, wait, nothing's happening. You do an ls, nothing's happening. However, if you were to type a command other than ls, if you want to test different commands, you do get a reply. This is in fact a real shell. Try to do ifconfig, and it says, screw off, ifconfig is not there. In this case, don't freak out. Just specify the full path of your command, and you'll actually be able to execute pretty much anything that's on there. So if you don't know already, the easiest way to do it is basically try it on your own computer. You could do the which command, so which ifconfig. It'll basically tell you where your ifconfig resides. Or you can basically locate ifconfig. And you'll notice that there's a decent number of them, really. I think there's even one in SBIN. Yeah, there is. So just basically just specify the full path of the command you're trying to run in this crappy shell, because when you do an exploit, sadly, half the time you're going to get a crappy shell. There's just nothing. So in my crappy shell, I do /sbin/ifconfig. And you'll notice that this is not, whatever value this is, it's not your own. You're on their system. And you're also root, by the way. So give that a shot. Let's see what you guys can do. For the record, you don't have to write down that -b and all that crap. Every exploit's different. Summary of this whole thing. So we'll just go over really quickly and we'll take a break. Everybody eat their pizza. For all of you who got your first root shell, congratulations. You're no longer one without a root shell. You're one with the root shell. You are root. Right. So we compiled the binary using GCC, as shown here. In a lot of cases, you end up having to add executable permissions when you use GCC to compile. So just keep that in mind. Sometimes it happens. And then you just run the exploit, right? And that's it for root. Now, it's important to note that in this case, I made it super easy, right? I'm just here to demonstrate that sometimes it's as simple as finding an exploit for a vulnerable service, exploiting them, and boom, you're root. But you're not always going to find it that simple. In fact, certain certification bodies will purposely make your life absolutely hell and make this process far more difficult than this. You will potentially see this scenario multiple times. There are other times you're going to get a user shell. You're going to get www dubs shell, right? You're like Apache. You're not even a real user at all. Yeah, that happens. There's going to be times where somebody went on exploit DB and Wikipedia it and changed like 5 things and now your whole exploit screwed up. That happens all the time. Other times there's, I don't know, firewall, there's like data execution prevention, just a bunch of crap to make your life hell, right? So yeah, we'll get into file transfer methods in a bit, but you guys have earned your pizza, so we'll take a break. All right, so I'm gonna go ahead and skip the privilege escalation exercise for now, because this one's a little bit harder than some of the ones I've hidden on the VM. So I'll walk through one of those instead to explain what privilege escalation is. And if you guys want to do this one after, that's fine. Before we do that, though, I'm going to show you guys a much easier way to get the root shell that we obtained earlier. So by show of hands, who's heard of the Metasploit framework? Should be most of you, right? Cool. So Metasploit framework basically automates a lot of the stuff that we do as pen testers. They've got modules. They've got different types of modules. So you have auxiliary, exploit, post-exploitation. Auxiliary modules basically perform certain actions. So you can log into an FTP server, you can launch some kind of web server, you can host files, whatever. You can scan, you can port scan, you can check for like eternal blue. Basically just a way of doing things, but in a much more centralized manner instead of having to have a bunch of loose tools like Nmap while you're trying to unicorn scan something, and it just gets confusing. The exploit modules, they actually carry an exploit and they execute a payload. So the main difference between auxiliary and exploit is exploit executes a payload such as a reverse shell, or maybe I don't know. Aside from reverse shell, you can pop a calculator. Like there's a bunch of crap you can do, but we'll worry about that later. Post exploitation, it does stuff like gathering. You can identify, credentials. You can steal SSH keys. It has basically automate tasks to do certain things. Requirement to use such a thing is because it's post exploitation. It means you have to have already exploited it. Right. So we're gonna go ahead. We'll walk through this together. So go ahead and start up the Metasploit framework in your terminal. I'll get your Callies up to it again. So you're going to type msfdb space run. That is going to launch your Metasploit framework database as well as the console. All right, so let me exit one of these guys. So go ahead and open up a new terminal or kill your lovely root shell. We're going to go ahead and get this started. So msfdb space run. You'll see it's going to start your database. It's going to launch console for you. Get a nice pretty banner. All right, and the same way that we did for search exploit, all we have to type is search, right? You'll know if you're in Metasploit if you have this MSF or MSF5 and a greater than. That just means you're in the Metasploit shell. All right. Does anybody not have this up on their screen right now? All right, so take 2 minutes. For those of you who already have it, just follow through the PowerPoint. It's literally the most straightforward thing. The only thing you can screw up really is the IP address, so give it a shot. All right, since it looks like everybody's got it up, we'll go ahead and continue. So we're going to search for a Samba exploit. So if you just search Samba, you're going to get a lot of results. I mean, probably too many. Look at that. It's like more than I care for. Now, the way Metasploit actually organizes their exploits and modules is it starts off with the type of module. So in this case, we have exploit followed by the platform or operating system. Then you'll have the service that's applicable and the name of that particular module. So for example, this one would be exploit for OSX for the Samba service, and it's called LSA transnames heap. All right, so obviously we're hitting Linux. So instead of searching for just Samba, we're gonna search for Linux/Samba. And that's going to basically find everything similar to these, right? We're going to look for anything that has Linux and Samba in it. That's going to narrow your results. Little tips and tricks like that reduce excessive data. Now we've got down to maybe about 5 exploits instead of 20 or 30. The next thing we're going to do is we're going to select the exploit Linux Samba trans to open module. To do that, you simply use a use command followed by the module that you plan to use. Pretty straightforward. So for example, if I want trans to open, so you simply type use, you can paste the name of it and hit enter. And you'll notice you go from just greater than, now it's going to tell you using this module, and you'll have that up in red. So you should have exploit Linux Samba trans to open, right? Does anybody not have this on their screen? All right, moving on. So if you use a show options command, it's very useful. It'll tell you like what you have currently set. So like your remote host, remote port, what payload you're using, that sort of thing. Just type show options, and there it is. So it tells you the module you're using. Pay attention to this particular one. So it says our hosts with an S. Some modules will have our host or our hosts as in multiple. So you want to know exactly what variable you're supposed to set. Do not assume that it's always going to be our host. So I'm going to use set variable that you want to set. So in this case, our hosts. And that's just going to be the IP address of the victim host. So in my case, 192.168.116.132. Or for most of you, probably your 56.101. So once you do that, the IP address is set. Run show options again. You should actually see it reflected here. All right, so we set our host. We're going to set our payload. So once you do set our host, your victim IP, then you want to set your payload. A lot of times it's already got a default payload. I believe for this one it's an interpreter shell, but for some reason it just fails against this host for me. So I'll show you guys why exactly I changed the payload before I actually do it. So I've got my R host set to my target. Our port is already set to 139 because that's what Samba resides on. So when I run it, show options run. Funny. All right, so as I'm trying to run it with my default payload, it tries to open up interpreter shells, but they keep dying. Why? I don't know. Welcome to cybersecurity. Everything breaks. I've got 4 sessions that basically said F off. So I guess that's what I'll do. We'll see, right? When in doubt, try harder. So try setting my payload to something else, because obviously it's trying to do an interpreter session. That's just a type of shell within Metasploit. If you guys really want to see the magic that thing can do, I can show you after this. All right, so I'm gonna set my payload, my one-handed command line foo. We're gonna do Linux, specify the architecture. I will do shell reverse TCP. Now, the sad part about this, and it happens to some, it doesn't happen to all. When you set your payload, there may be additional options that you have to set. So when in doubt, show options, make sure you have everything. So I saw for a few, it cleared the lhost parameter. So some people actually had to reset that, which is kind of annoying. But again, welcome to cybersecurity. Everything breaks. It's okay. We will try harder. So make sure the remote host is set. You've got the port. On our payload, you'll notice now there's payload options, right? So instead of the default, now we've got a reverse TCP shell. It tells us who's going to receive the shell. That is your IP address, or should be your IP address. Okay, don't give them their own shell. It's just weird. All right, and then the port. So because I'm annoying, I'm going to set my L port to 1337 because late, and run it. And so it's going to brute force the address, and when the exploit succeeds, I should get a shell at 1337. There it is. So coming from them. Oh yeah, no, it's my listener. I'm connected to them. Now I have a command shell. So now you can actually start running commands. So let's run an ls. It's empty. pwd, so we're in temp. So you treat it like a regular shell. Boom, I'm in the machine, right? So you can tell Metasploit is a lot easier than downloading a C program and compiling it into a binary and reading it, going through it, and trying to figure out, okay, what flags am I supposed to use? Am I sending a shell to somewhere in China? I don't know what the heck's going on. Metasploit's a lot safer. It's community built, based, and maintained. So when in doubt, try to look there. For certain hacking exams, those of which I won't name for legal purposes, you can't really use this a whole lot. You're only allowed to use it one time. Okay, so understand while Metasploit is extremely convenient, you will learn most of the manual methods. All right, so don't rely heavily on it. that brings us to our next piece. All right. So everybody should have credentials to log into the VM as a user. We are going to wander into the realm of privilege escalation. All right. So if you guys check your Slack, I've included the credentials. We're going to go ahead and log in using those credentials as a user and escalate our privileges to root. So you're going to go to the VM that I gave you guys. You're going to log in. Actually, I have to use 2 hands for this password. And once you logged in as a user, just navigate to the slash directory. Go and run a ls. And you may notice some very interesting folders here. So there's a few of these in here, and I'm not going to cover all of them because I want it to be a little bit challenging, a little bit fun for you guys. This is a workshop. So yeah, log in and go to slash directory and go to the vuln custom bins directory. And there's some juicy stuff waiting for us. Oh, well, that's VMware's full screen for you. Is everyone logged in right now? Is anybody not logged in? Okay, but just go ahead. Wait, maybe 3 minutes. All right, so I'm going to give you guys one walkthrough of one of the vulnerabilities I created on the system. All right, that is set GID. Okay, so if you take a look, if you do ls-la inside of your slash vulns underscore custom bins folder, you'll probably notice that the permissions are set a little weird. Okay, this is because I've set this binary to run with the power of the group associated with it. So if you don't understand Linux permissions, it's definitely worth a Google. But the long story short is bash, I've copied it to this directory, and it's owned by root, and it's owned by the root group. Okay. Now the special permissions set here are such that when executed, it will execute in context of the root. I'm sorry, the root group, not the user that runs it. People do this a lot to basically give binaries or basically allow users to run binaries with pseudo privileges or with, as super users, or maybe with permissions of certain groups or other users, not always root. But in this case, this lazy sysadmin said, you know what, I'm going to make it to where this particular bash can basically run everything, right? So if you cap the lovely README I wrote up, it's a nice, cute little story. Long story short is everything I just said. I'm just saving you like 10 minutes of agony of dealing with my crap. So if you cat the README though, it'll actually tell you to use this. This is just one example. Goodness. And so long story short, look at that. There's like adorable little chicken there, cyber chicken. So you cat, type it into less because we don't have a very tall screen. And it says basically to use this thing's ability, you specify bash-p, and when it executes, it's basically going to launch a new bash as root. Right? Now, before we do this, do an ls and try to cat imgroot.txt. If you noticed before, if you do an ls-la, imgroot can only be read by root, nobody else. So if I try to cat it, you should get permission denied. It just says, hey, you're not root, go away. Right? However, if I run bash, suddenly my shell changes, I get to ask, who am I? Remember what I said. When you launch this binary, it's going to execute under the context of the group that owns it. Kind of weird. So now I'm root because I've executed this bash under the root context. Now I can cat, I am root, and congrats, I have bypassed the restriction on my account. That's an example of SGID. All right. If you want more details, you could read the readme.txt in there, or you're welcome to Google that. I mean, it's something you're gonna have to learn anyways. But privilege escalation is basically the art of circumventing restrictions on your account. So if you don't have privileges, which you'll get a lot of times as www data or some kind of user or service, this is something you're gonna wanna be familiar with. Privilege escalation can be done in a lot of manners. It can be done through misconfigured services. It can be done through a vulnerability in MySQL when there's no password for the root user. There's like this crazy LDF or UDF exploit. You guys can look that up later. But just know that when it comes to privilege escalation, it's not always about downloading a kernel exploit or finding credentials somewhere. Be creative. Look at the permissions of binaries. Look at the things running. Look at the kernel, right? There's a couple different challenges on this box. I will leave it to you guys to do that. If you want to go over the kernel exploit or several others, yeah, you can come see me and I can walk you guys through it. But this is now in the state of the challenge, so enjoy. They're calculating. Do you guys already get the CTF results? No, you guys didn't. All right, so we're working out CTF results right now. We're at the social hour, so you guys are welcome to move around, socialize with each other. If you guys want to learn more about privilege escalation, I can continue working with you guys up in these front rows here because I'm going to turn off the mic.